Okay, so in the numerical methods, let's spend one second. So, so in the numerical methods, so first we have that Taylor series, and the next one is Euler's method, and next third one is modified Euler method, modified Euler's method, and the fourth one is Rangakutta method. So there are second order and fourth order will be there. So these are the four methods in that numerical method to solve the differential equation. So we are solving the differential equation by these four methods. Okay. Now first we are going to discuss about the Taylor series. Yeah. So first we'll go to discuss about the Taylor series. Taylor series. Okay. So this is considered that first order partial differential equation dy by dx equal to f of x comma y. Okay, and that initial values that y of x naught equal to y naught. Okay, then we are expanding the Taylor series. So Taylor series. So Taylor's series at the point here is there, no, this point. So at the point x equal to x naught is, that is, so y equal to the phi of x naught plus x minus x naught into, so pi dash of x naught plus x minus x naught whole square into pi double dash of x naught . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So plus so on. So this is the Taylor series expandation. Okay. So when you're doing the one problem and you will get it everything. So how we can find that pi of x naught and how we can find that pi dash of x naught, that everything we are getting through that. So we'll do one problem. So find by Taylor series method, find the values of y at x equal 0.1 and at x equal to 0.2 up to 5 places decimals. Okay. Uh, so here dy by dx equal to x square minus 1. So x square minus 1. So we are getting that plus. We'll do one example problem in your textbook. So in your textbook, the one problem will be there. So using Taylor series, find solution of to find the solution of x y dash equal to x minus y, and there initially they given y of 2 equal to 2. So we need to find at x equal to 0.1, x equal to 2.1. Okay, see this one. So see the solution. So first we are writing, so y dash, what are they given, that we can, the first we can write that. So this is become x naught. So that x naught equal to 2. And this is become y naught. So this is y naught equal to 2. Okay. Uh, and we need to find what is that uh, at the point 2.1. So x they given x naught value 2 they give, we need to find x equal to 2.1. So from there that's become h equal to become uh, the 2.1 minus 2. So that's we can write 0.1. Okay. So first y dash. So from here we can write y dash equal to. So y dash equal to x minus y by x. So that's become 1 minus y by x. So that's we can write 1 minus y naught by x naught. That is 1 minus y naught is what is that? 2. So 2 by 2, that equal to 1 minus 1. 1 minus 1 that equal to 0. Okay. This is y. So next we need y double dash. So now we need to differentiation of this thing. Okay. So first derivation, that one derivation is 0 minus, you have to apply u by v formula. This is u and this is v. So u dash, that is nothing to y dash. So y dash into x minus y into 1 by x square. Okay. So from there we are getting what is it? Y by y into x by x square plus y by x square. And 1 x get cancelled. So y double dash equal to y by x, y dash, or this is y dash. So y dash by x and y by x square. Now that is we need to find y dash of 0 by x naught and plus y of 0 by x naught whole square. So then from where we are getting to 1 by 2. Okay. Now this all values, so we have to substitute there in that formula. What is the pi dash of x naught? What is the pi double dash of x naught? So all the values we have to substitute there. Okay. Then we are getting to that value at 0.2 at 2.1. We are getting that. Okay. See, share the PDF. Let's see here the one problem. So dy by dx equal to x square y minus 1, y of naught equal to 1. And so from here, dy by dx. So this is become, what is that? X naught, and this is become y naught. So dy by dx equal x square minus y minus 1. So first we are doing the derivations. So y dash, so that is x square y minus 1. So y double dash here apply to the UV formula. So when you are applying to the UV formula, that is become this here. I will explain. See there. X square y minus 1. So this derivation, that is 2xy plus x square is as it is, and y derivation is become y dash of 0. So this is 2xy plus x square y dash plus 0. So that is y double dash. So at the point, then we are getting that minus 1, and y naught double dash equal to that we are getting 0. Okay. Next, y triple dash. So what is the y triple dash? So again, we need to do differentiation of this. What is that is 2xy plus x square y dash. No? Now this differentiation is become uh, 2 outside, then y plus x into y dash. Okay. Plus this differentiation. See here. X square means 2x y dash plus x square into y double dash. So that completely that we are getting 2y into 2xy dash plus 2xy dash, that is become 4xy dash plus x square into y double dash. So at the point x equal to 0 and y equal to 1, and we are getting the values of y triple dash. And in the same thing, you need to find that y fourth derivative, the fourth derivative of the y. Then we are getting that minus 6. Okay. Now we have to substitute that all the values in the Taylor series. So what is that? Y equal to y naught plus x minus x naught into y naught dash plus x minus x naught whole square by 2 factorial into y naught double dash plus x minus x naught 3 whole cube by 3 factorial into y naught double dash plus so on. So already we find out that y naught, y dash value minus 1, y double dash is 0, and y triple dash is 2. So all the values we can substitute. So 1 plus x minus x naught. So where we are, that is x naught is 0, no? So we are getting one polynomial function. Okay. So that after getting that polynomial function, we can find out that any values. Okay, na? If they are asking to find the value of y at x equal 0.1 means, so in place of x, we are substituting the 0.1. And if they're asking the next one, they're asking to find the value of at x equal to 0.2. So when x equal to 0.2 means, then we are getting this. So if from there we can find out that x equal 0.3. Suppose they're asking to find the y value at x equal to 0.3. So just we can substitute here. So in place of x, we have to substitute 0.3. So 1 minus 0.3 plus 0.3 whole cube by 3 and minus 0.4 by 4, 0.3 whole power of 4 by 4. Now we'll do the second problem. But y dash plus 2y plus 2 e power of 3x. So y dash is 2y plus 3 into e power of 3x. And here the given y of 0 equals 0. So this is become x naught and this is become y naught. Uh, so this is x naught. So x naught equal to 0 and y naught equal to 0. So first we are doing the differentiation. So here we can substitute that y equal to 0. That is 2 into 0. Yeah. So this is that y naught and y double dash. So next we have to do the y double dash. So this is y dash no, and this derivation. So that is become 2y dash plus 3 into e power of x. Again that this is y double dash. So y triple dash. So the 2 into y double dash plus 3 into e power of x and fourth double dash. So all the values we can substitute there. And we are getting the Taylor series. Students, you can do that problem as a homework. Y dash. So y double dash. That is x derivation is 1 and y square is 2y and y derivation is y dash. And similarly, you have to do third derivation, fourth, fifth. So this is x naught equal to 0 and y naught equal to 1. Students, you can copy these problems to solve these problems more. Euler's method. Okay. Uh, Now that given differential equation the dy by dx equal to f of x naught comma y naught. Yes, no? So now that we can write dy equal to dx into f of x naught y naught. Now we have to do that integrate on both sides. Okay. So that's become y naught to y1 into dy, and this is x naught to x1 f of x naught comma y naught into dx. So that is 1 into dy is y. Okay. And this we writing as it is x naught to x1 f of x naught comma y naught into dx. So y1 minus y naught equal to x naught to x1 f of x naught comma y naught into dx. So y1 equal to y naught plus x naught to x1. So f of x naught y naught into dx. So this is Euler's formula. Okay. Now similarly that we can get the y2. So we can get the y2. So y1 plus this one we are getting. So I will show that. So x1 minus x naught that we are taking the h. So y1 equal to h into f of x naught minus x1. So this is, so when you are taking to this one, so here that's become x1 minus x naught into f of x naught minus y naught. That's I'm telling about that y1. So that y1 equal to y naught plus h into f of x naught comma y. So from here we can write yn plus 1 equal to yn plus h into f of xn comma y. So this is the tubular equation. So we'll do one problem. See that using the Euler's method, find the y of 0.5 for the differential equation. So dy by dx equal to y square minus x square with the y of 0 equal to 1. Okay. That means, so this is become x naught equal to 0 and y naught equal to 1. So this is f of x comma y. So y 0.5, no? So we are dividing into 5 intervals. So h equal 0.5 by 5. So we are getting that h value is 0.1. So x naught they given 0, no? So x1 is become x naught plus h. So that's become 0 plus 0.1. That equal to 0.1. Then x2 is same thing. x1 plus h. So that is 0.2. And x2, x3, x4, and x5. So we have the Euler's formula, no? So that is y of n plus 1 equal to h into f of x and yn. So for n equal 0, so first we are getting the y1. y1 equal to y0 plus h into f of x0 y0. So y0 is 1, h is 0.1. And f of x0 y0 means that is y0 whole square equal to x0 whole square. So already we have that y0 equal to 1 and x0 equal to 0. Then we are getting y1 equal to 1.1. Okay. And for second approximation, that y2 equal to y1 plus h into f of x1 y1. Then y2 we are getting for n equal to 2 and we are getting that y3 and n equal 3 and n equal to 4. So they're asking to here find that y of 0.5. That means we are doing that 5 interval. Suppose they are asking to find y of 0.2. Okay, then we are getting that only this thing, y2. Now see the second one. So they're asking to find out y of 0.04. So they're taking, we need to take that h equal 0.01. So this is x naught. So x naught equal to 0. Then x1 is become 0.001 and x2 is become sorry 0.02. Sorry, no, this is so 0.04, no. So we should add, then we are getting x1. x1 0.01 and x2 0.02 and x3 0.03 and x4 0.04. So we are getting to that. the first approximation, and second approximation, and third approximation, and we are getting the fourth approximation. Why? Because they are asking to find 0.04, no? So that's why we have to get. Just one see the problem. No? So this is the things. Now let's see the one more problem. Student, let's solve this one. So this is that formula. Yn plus 1 equal to Yn plus h into f of And see that one more problem. So this is so one thing today what we are learning means so Taylor series means y of x equal to y naught plus x minus x naught into y dash of x naught y naught plus x minus x naught whole square by 2 factorial into f double dash x naught y naught and plus x minus x naught whole cube by 3 factorial into f triple dash x naught y naught. Okay, so this is the Taylor series. And what is the Euler's series? Euler's method. So yn plus 1 equal to yn plus h into f of xn yn. So suppose n equal to 0, then we are getting y1, y naught plus h into f of x naught comma y. Similarly, that y2 equal to y1 plus h into f of x1 y1. So this is Euler's method. So this is Euler's. So you should remember this one. Y of n plus 1. Y2. Okay. The Taylor series and Euler's method. Just you should remember the formula. So if you remember the formula, and it's very easy. So one thing in the numerical methods, all problems are depending on